So, you want to learn about physics and music.
Well, you're in the right place. For every instrument, for strings, you typically have 4 open strings and they all vibrate at different frequencies. So for the cello, A3 is 440 hertz, D3 is 146.8 hertz, G2 is 98 hertz, and C2 is 65.4 hertz.
For trombone, the trombone is typically tuned to a B flat 3, which is a 115.2.
So, the friction created between the string and the bow hair is what produces the sound. And it is necessary for there to be rosin on the bow hair, which is just hardened tree sap essentially, to grab onto the string, which produces more friction and sound on the string. All string instruments respectively, the musician is in charge of how the sound is received. So they're able to control the amplitude through dynamics and different timbres. So, for example, differing bow pressure, you can't see this, but you can just imagine you can. Less bow pressure would result in a piano, and more would result in a forte. They can also use different timbres, which is just tone quality, that can be determined through different articulations, like legato versus spiccato. Another concept in sound provided by the cello is resonance. When you play a note, it can vibrate at different frequencies other than the primary pitch. This is otherwise known as sympathetic vibrato. To do so, you vibrate the primary pitch, but just at the higher and lower octaves in the string. So this is just a flat pitch, but then you can... These outside frequencies will then align with the primary pitch and overtones, which can cause them to vibrate in sympathy. This brings the cello to resonate in subtle yet complex ways, which alter the tone quality.
So, with the trombone, how sound is made is actually different than on the string. With the trombone and any brass instrument, how it starts out is the musician starts buzzing their lips. But that is how the vibration is created and how the sound starts. When the musician buzzes into their mouthpiece, they can create more of a pitch or a certain frequency on it. And so, well, that does create a pitch. It's not quite true sound for it, or music sound, because in order for it to be the right note, it needs to be the proper length, which that's what happens when you put it onto the instrument. Now, for any brass, the main way of changing notes is changing the length of the instrument. So, it's fairly simple to see on trombone here, because you're going to start out on a certain note, and the longer you put the slide, the lower the note is going to be. Other brass have a different version of this, which they typically use valves, where there's slight tubing attached to each valve, so when it gets pressed down, the air then runs through that valve, increasing the total length of it. How the sound is actually produced is there's actually a longitudinal wave happening throughout the instrument. So as it goes all the way through, once it reaches the horn of it, the wave actually doubles back on itself, but loses a slight amount of energy in there. It's that lost energy that we perceive as sound, or music in this case. So when more energy is lost at that point, that results in a higher frequency. The other way to change just how much energy is going to be lost is how fast the air is traveling within the instrument. Now, for brass, we call those partials. So the faster you put air through the instrument, that's going to cause the pitch to go higher and higher. And then from there, you're able to adjust the length and get more notes out of it. Alright, so all sound is transmitted through longitudinal waves. Now, music uses this in order to transmit pitches and frequency so that all sorts of chords can be made in music. So the parts of the longitudinal wave, up here is the compression, So that is the close part of it. And right behind it would be the rarefaction. Now on this model here, you can see the wavelength right there, but there is another part that is more difficult to see with this. So on this other model, more of a slinky, it's easier to see the amplitude, which would be right here. And amplitude in music typically responds to dynamics and is a major part within music.